The amount of jitter in action potentials elicited during axonal stimulation or during voluntary activation can be appreciated and estimated from both their appearance on the screen and from their sound on the loudspeaker. We will demonstrate this in 3 recordings made with voluntary activation with increasing amounts of jitter. All signals are shown with a sweep setting of 0.5 milliseconds per division. Listen to the variation in the sound and observe the superimpositions of the non-triggered potential. The first recording has low normal jitter. Here the discharges are superimposed. The positive and negative peaks of the triggering potential are separated by less than half a division. This gives it a rise time of less than 250 microseconds. The short rise time gives a sharp, crisp sound to the signal. The sound of the potentials was relatively constant throughout this epoch. This indicates little variability of the interpotential interval, thus normal jitter. The rising slope of the triggering potential appears very thin and sharp because it's always displayed at the same position on the screen. The rising slope of the non-triggering potential is just a little thicker than that of the triggering potential. This indicates that the jitter is not only normal in this pair of potentials, but is in the lower part of the normal range. In this plot of sequential values, the interpotential intervals show a very slight change on successive discharges, and there's no trend. By visual assessment, there is no significant correlation between the interpotential interval and the interdischarge interval, indicating that there was little effect of the velocity recovery function. The mean interpotential interval is 480 microseconds. Both MCD and MSD are 10 microseconds. The jitter is recorded as 10 microseconds. In this recording, we can clearly hear the variation in the EMG sound, and it was also easy to see the slight variation in the position of the non-triggering potential, especially when the discharges are superimposed. This indicates more jitter than in the first signal we presented. Still, the non-triggered potential shows good superimposition, indicating normal jitter. The rising slope of the second potential appears much thicker than the rising slope of the triggering potential, and the jitter is in the mid to higher part of the normal range. The plot of the interpotential intervals here shows more variation among the data points, indicating greater jitter than in the previous pair of potentials. There is no trend or velocity recovery function effect. The mean interpotential interval is 1452 microseconds. The MCD is 40 and MSD is 41 microseconds. The jitter is recorded as 40 microseconds, which is the MCD value. In this recording, the change in EMG sound and the visible jitter in the second potential were very obvious. This amount of variation in sound indicates abnormally increased jitter. You could also hear the different sound when the sweep contained a pair of potentials versus when the second potential blocked. The jittering potential appears smeared here on the screen due to poor superimposition. In some discharges, shown here in red, There was no second potential due to blocking. Here are 10 sweeps shown in the raster mode. Note that the second potential has blocked in some discharges, indicated here by the arrows. To be sure that this was non-technical blocking, we look at the triggering potential, which has a constant waveform. Back in the superimposed mode, we can confirm that the triggering potential has a constant waveform. This assures that we have recorded discharges from a single motor unit and rules out technical problems such as missed triggers from other motor units. Here in the traces indicated by the arrow, we can see the baseline where the non-triggering potential is expected, which makes it easy to recognize the blocks. The sequential interpotential interval plot shows a marked degree of scatter. The mean interpotential interval is 1831 microseconds. The MCD is 196 and MSD is 236 microseconds. The jitter is recorded as 196 microseconds and corresponds to the MCD value. With such high jitter, blocking is expected. In this recording, 39 sweeps had blocking. I will now play the audio of these 3 recordings in a different order. Listen to the sounds and see if you can match them to the correct jitter value. Details about jitter and blocking can be found in Chapter 6 of the Single Fiber EMG monograph. A discussion of the MCD-MSD ratio is on page 54 of that chapter.